Hello everyone, today we are going to study circle geometry. So if you consider the circle with center O, this portion is what we call the sector of the circle. Actually, we often call it the minor sector. And this curve, let's call this curve AB, is often called the minor the minor arc. Okay. Now, this line segment, let's say from D to D, is what we called the chord. That's the chord of the circle, and this chord gives us what the area under the chord gives us the minor segment. Okay, good. Now there are some things we need to know before we move ahead. Very important when it comes to the chord. Okay, when it comes to the chord, the line from the center of a circle, okay, the line from the center of a circle to the midpoint of the chord or of a chord, the line from the center of a circle to the midpoint of a chord is always perpendicular to what? To the chord itself. What are we saying? We're saying that if here's center and we have the chord over here, the line from the center to the chord such that it meets at the midpoint of this chord, making these two parts equal. Let's say this is the chord AB. We're saying that it is perpendicular, that this line is perpendicular to the chord. That is, this angle is 90 degrees. Okay, that is what we mean. Very important fact. Now we'll go into the basic propositions of circle geometry. This is actually 2.3.1. 2.3.1. Okay. Now there are many propositions here. We'll start with proposition 1. Very popular proposition. Proposition 1. Proposition 1 says, before I give you the proposition itself, okay, let me give you the proposition first. Proposition 1 tells us that the angle which an arc, okay, of a particular circle subtends at the center is always twice that which is what? subtend at what? At any point. At any point on the circumference. Okay, what does this literally mean? Let me give you some picture view. Let's say consider the circle here. So this is our origin. Now this is what we are trying to say. We are trying to tell, if you consider this arc AB, the angle subtended by this arc AB, let's say, okay, I messed up. It's like this, and yeah, like this. Yes, exactly. This angle subtended by this arc AB this is the origin. Don't worry about this line, it's a mistake. Now this angle here, we are saying that it is 2 times this angle here. So if I call this angle x, then this angle is 2 times x. This angle is 2 times x. Okay. Also, there's another form we can have. We also have, let's say this is center, and the origin, still the same thing. So this angle here, this angle it makes is twice this angle. Okay, twice that angle. So if this angle is y, we expect this angle to be 2y. What else? Okay, that means this is A and this is B. Okay, let's call this point P, call this point P. Yes. I think these are basically what the proposition is telling us. Okay. So the point is what? The point is the angle AOB is always 2 times what? The angle what? APB. Okay, that is proposition 1. Proposition 2. Proposition 2 tells us that the angles in the angles in the same segments of circles are always equal. That is, the angles in the same segment of circle are equal. That is, if you consider the circle here, then we have a segment. Consider for this segment, you see, if I trace a horizontal line like this is just one segment, this is the second, this is actually the major segment, this is the minor segment. So for this segment, this angle here with maybe this other one form in the same segment, they are equal. This is what we mean. So if I call this A and call this P, and maybe call this point P and call this point Q, okay, what we are trying to tell you is that angle APB is equals to angle AQB Okay, that is our proposition 2. So proposition 3. Proposition 3 is simple. It says that the angles in semicircle are what? Are 90 degrees. That's the angle sustained by this measure arc. Let me show you. So I said this is the center and this is the diameter. We call this AB. So clearly this is a semicircle, this is another semicircle, and we are saying that this angle here or this one, they are all what? 90 degrees. Let me call this P and Q. We are saying that angle APB is equals to angle what? AQB, and they are all what? 90 degrees. That is what proposition 3 tells us, that these two angles are all 90 degrees. Proposition 4. Proposition 4 tells us that the angles in opposite sides of segments are supplementary. Okay, or another way you can say that, you say the angles in the opposite side of a cyclic quadrilateral or what? Supplementary angles that sum up to 180 degrees. So we can take a picture here. So we have this, I call this A, B, C, and D. We are saying that these angles are clearly supplementary angles. Is opposing. That is angle ABC plus what? Angle CDA is equals to what? 180 degrees. And what? Angle DAB plus angle what? BCD is also what? 180 degrees. As this angle plus this angle is 180 degrees, and this angle plus this angle is 180 degrees. So that's proposition 4. Proposition 5. Proposition 5 is, it follows a bit from here. So we can say the exterior angle for a quadrilateral, if I extend this, I have an exterior angle, that the exterior angle will have, if I extend this line, will be equals to the opposite interior angle. That's proposition 5. So the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, like see that these, so we have Good. Now we are saying this angle here is equal to this angle over there. Okay, so if I call this A, B, C, D, E, we are saying that angle ABC is equals to angle CDE. Yes. Proposition 6. Proposition 6 tells us that a tangent is always perpendicular. That is, as an angle of 90 degrees, always perpendicular. Now this perpendicular. See, okay, perpendicular to the yes, to the radius. It's perpendicular to the radius. To the radius at the point of contact. That is, if you consider this circle, see this is perpendicular to this circle, so this is the center. Now this is the radius. The angle it makes with this line, this is the line we call the tangent line. Tangent line. Okay, so this angle it makes with the radius is always 90 degrees, always. Okay, that's what this proposition 6 makes us understand. So proposition 7. Proposition 7 uses a bit of this idea, but in a kind of different way. Here we have a circle. So here's the tangent line. Then we have let's look at this. Okay, and then let's say we have an inscribed triangle. Good. Okay, now we observe that this angle here is always equals to what? This angle here. Okay, so if I call this A, B, C, we are saying that this angle, okay, let's call this P and Q. We are saying that this angle QAC is equals to the angle ABC. Okay, that's what proposition 7 tells us. So how do we put it in words? We can say the angle between a tangent to a circle and the chord. Yeah, this chord and the chord through to the point of contact. Are equal. Supposed to be is equal to the angle in the alternate segment. This is the alternate segment on this segment, alternate segment here. So this angle is equals to this angle Same thing here. So if I call this x and this y, what we are trying to say is that x is equals to y. Also, we're also saying, also same thing applies here. If we consider this segment instead, I'll call this a, this angle b. We're also saying that a is equals to b. Okay, that's what we are saying by proposition 7. Okay, so in a more general way, we can say angle QAC is equals to angle what? ABC. Okay, and angle PAP is equals to angle ACB. Yes, yes, and yes. Okay, position 8, we have that the tangent to a circle from an external point are equal. The tangents to a circle from an external point are equal. Like, consider the circle, center, let's say the point is this far from the center, so the tangent, this tangent also, we're saying that these tangents are equal. First of all, we do know by proposition 6 that this is 90 degrees, this is also 90 degrees as a radius of the circle, and this is a point here, we can call this point P. Let's call this A and B. So we are saying that this line here, these tangents are equal both in size and angle. This angle, by the way, is equal to this angle. Also, this angle here is equal to this angle. Okay, that's it. So that's what we mean by that statement. So we can say angle AOP is equals to angle what? EOP. Okay. Also, we have angle PPO equals to angle what? APO. Very important. These angles are equal. What else? Yeah, of course, angle A. We saw that already, equals angle B, and they are what? 90 degrees. And finally, the side AP is equals what? VP. these are the properties we pull out from this proposition 8.